बिस्मिल्लाहिर्रहमानिर्रहीम। अस्सलाम वालेकुम। लास्ट टाइम आपने virtual वर्क में दो अप्रोचेस पढ़ी थी to solve the virtual work problem. The one approach was geometrical approach and the other was mathematical approach. Geometrical approach में हमने beams problem solve किए थे और आज हम mathematical approach को एड्रेस करेंगे और इसमें मैकेनिज्म और मैकेनिकल प्रॉब्लम सॉल्व करेंगे। तो वर्चुअल वर्क को यहाँ पे एक दफ़ा फिर डिफाइन कर लेते हैं। वर्चुअल वर्क, इफ बॉडी और सिस्टम इज in equilibrium under application of many forces, then the sum of all virtual work done by all forces due to virtual displacement of their point of application will be equal to 0. This is called principle of virtual work. Mathematically, it can be written as del W, that is virtual work, equal to force F1 into small virtual displacement ds1, force 2 into displacement 2, F3, force 3 into displacement 3 equal to 0. Procedure to solve virtual work mechanism problem is, the first point is to consider or select an origin point in the system which is generally a fixed point. Number 2, mark the coordinates of point of application of all external forces with respect to origin point. 3, select the coordinate in the direction of force and get its differential form for virtual displacement. 4, apply principle of virtual work and take the forces with their sign positive or negative as their direction. ये प्रॉब्लम अब सॉल्व करते हैं हम। प्रॉब्लम की स्टेटमेंट, प्रॉब्लम 1 स्टेटमेंट, फाइंड द फोर्स Q, दिस इज द फोर्स Q for the equilibrium at given position. Given position is theta is given. Both the bars are identical and massless. These two bars AB and BC are massless and identical. Where P is given, this force is given 50 Newton, length is L of each bar, and angle theta is given, this angle is given as 30. So this is the problem mechanism given, and जब हम इसको सॉल्व करते हैं तो जो हमारे प्रोसीजर्स के मुताबिक, the first point is consider an origin or select an origin. तो ये हमने x y कोऑर्डिनेट्स पे origin point A select, इसमें क्योंकि फोर्स P एंड फोर्स Q ये जो हैं, ये अब अगर इसको फोर्स P को अप्लाई करें ऊपर से तो ये मूव करेगा, पॉइंट B जो है ये पॉइंट मूव करेगा, न्यू यहाँ इस पॉइंट पे आ जाएगा, और ये पॉइंट C जो है मूव करके इस पॉइंट पे आ जाएगा। अगर यहाँ पे हम फोर्स अप्लाई करते हैं तो यहाँ पे फोर्स चाहिए जो इसको बैलेंस करे। तो फर्स्ट पॉइंट इज टू सेलेक्ट द कोऑर्डिनेट। तो ए कोऑर्डिनेट, point A is a coordinate which is a fixed point, and coordinate of this is 0 0. The second step is mark the coordinate of POF all the external forces. Mark the coordinate. So coordinate of point B is XB YB, and coordinate of force Q is point C is XC YC. third point is select the coordinate in the direction of force. तो यहाँ पे हम जो है in the direction of force पे YB select किया है coordinate, और यहाँ पे जो है XC in the direction of force Q फोर्स अप्लाई हो रही है, तो इस डायरेक्शन में जो है XC है, और यहाँ पे YB सॉरी ये P अप्लाई हो रही है, और इसकी कोऑर्डिनेट का जो डायरेक्शन है YB होगा, दिस डायरेक्शन. So YB is the coordinate of point B. So this will be equal to L cos theta. This distance is equal to this L cos theta, and differential of this dyb, this virtual displacement, equal to minus L sin theta into d theta, and XC will be equal to 2L sin theta, and differential of this will be equal to 2L cos theta d theta. And application of virtual equation equal to del W equal to minus Q into dxc plus minus P into dyb equal to 0, where Q is the external force and P is also an external force, dxc is virtual displacement, dyb is this displacement. तो then put the value of, यहाँ पे हम dx की वैल्यू और dxc और dyb की वैल्यू पुट करें, तो dx की वैल्यू 2L cos theta into d theta, and dyb की वैल्यू माइनस ये वैल्यू माइनस L थीटा इंटू डी थीटा इक्वल टू 0. तो सिंप्लीफाइंग जब इसको हम सिंप्लीफाई करेंगे तो ये जो है minus Q2 cos theta plus P sin theta equal to 0, and from this Q will be equal to P tangent theta over 2, and we put the value of P and tangent theta 30. This is the given value of P, and this is the given value of theta. So the calculation of Q is 40.43 Newton. Another problem. This is the mechanism, bar AB and bar BC. The problem statement is find the force P. ये फोर्स मालूम करनी है टू कीप सिस्टम इन इक्विलिब्रियम एट गिवन पोजीशन. बार्स आर आइडेंटिकल विद वेट W एंड लेंथ L. पिछले प्रॉब्लम में वेट लेस बार से वेट इंक्लूड नहीं था, इस मैकेनिज्म में वेट भी इंक्लूड है, और इसलिए यहाँ पे जो है 3 फोर्सेस एक्सटर्नल फोर्सेस एक्ट कर रही हैं. P W bar, this bar weight downward and this bar weight downward. So 3 forces, external forces are acting. The first step is to select origin. So this is fixed point, coordinate A is fixed as a origin, and this coordinate of this point is 0 0, and coordinate of point B is XB YB, coordinate of D point is XD YD, and coordinate of E is XE YE. And third step is select the coordinate in the direction of force. तो coordinate in the direction of force, For this force, coordinate is selected as YD, and for this P, this coordinate is XB, and for this force W, the coordinate is YE. So XB will be equal to L cos theta. This XB will be equal to cos theta, and if we differentiate this, dXB will be equal to minus L sin theta d theta. The differentiation of cos theta is minus sin theta. Then YD will be equal to minus L by 2 into sin theta. This is L by 2. This distance is L by 2 sin theta, minus L by 2 sin theta. The differential of this is minus L by 2 cos theta into the d theta. And YE is equal to minus 3 by 2 L sin theta. The differential of this will be minus 3 by 2 L cos theta d theta. So applying the virtual work equation, del W equal to force into displacement, virtue displacement. This is force and virtue displacement is dXB. This will be dXB plus minus W into dYB, dYD, this, and plus minus W into dYE. This will be equal to 0, and put the value of dXB and dYD and dYE, these values in this equation. These are the three forces, P, W of one bar and second bar. So after simplifying, P sin theta equal to 2W cos theta, P will be equal to 2W cotangent theta. If we have a value of W and theta, we can calculate the force P. Another problem. This is mechanism given. The problem statement is find force P for equilibrium at given position. Bar AB having a length L. This bar AB having length L. This total length is L. And weight of this bar is W. So यहाँ पे दो external forces हैं, P and W, weight of the bar. So the first step is to fix a origin point. So this is point O is origin point with coordinate 0, 0, and coordinate of B will be XB, YB. Coordinate of C will be XC, YC. Coordinate in the direction of force will be phi C, where YC in this for this force, and XB for force P at point B and point here point C. So XB will be equal to L cos theta. This distance will be L cos theta. This angle is theta, so this distance will be L cos theta, and differential of this will be equal to minus L sin theta into d theta. YC equal to L by 2 sin theta. This distance will be L by 2 sine theta. So YC will be L by 2 sine theta, and differential of this will be equal to L by 2 cos theta into d theta. By applying the virtual work equation, force into virtual displacement, sign is minus because it's acting in leftward, and dxb is virtual displacement at point B, minus W into dyc. W is this force and dyc is this value, and putting the value of virtual displacement dxb here, dyc here, and simplifying, P will be equal to W by 2 cos theta or sin theta equal to W by 2 cotangent theta. If we have a value of theta and W, we can calculate the value of P. This problem is a loss problem. This mechanism, 3 loops, and the bars, the distance is given, theta is also given, all members are weightless, joints are frictionless. The problem statement is find the relation between P and Q. This force is external force is acting P at this point A, and this Q is acting on point B. This point is B. Statement is find the relation between P and Q for equilibrium of the system at given position. So the first step is consider an origin. तो ये origin, ये point O हम select करते हैं इसको origin. This is fixed point, and this coordinate will be x and this y. So this point is A and this point is B. So XA is equal to 2A cos theta. XA, this distance is A cos theta plus A cos theta, 2A cos theta. And if we differentiate this, dxa will be equal to minus 2A sin theta d theta. XB is equal to 6A cos theta. 6A cos theta, this 2A, then 2A, then 2A, 6A. This total distance is XB is 6A cos theta. And if we differentiate this, minus 6A sin theta into d theta, this will be, if we apply the virtual work equation, this will be force P into virtual displacement dxa plus force Q, the sign will be minus because the lifting. Applying the virtual work equation, P force into virtual displacement dxa plus Q, the sign of Q will be minus, it's acting leftward, into dxb virtual displacement. Put the value of dxa and dxb in this equation, and cancelling the common values, and after simplifying it becomes 2p is equal to 6q and p is equal to 3q. So for equilibrium, p should be equal to 3q. So this is all for this lecture. इसके अलावा आपको मैं असाइनमेंट नंबर 3 भी दूंगा और इसके साथ अटैच कर दूंगा इस लिटरेचर के साथ, और नेक्स्ट टाइम हम नया टॉपिक स्टार्ट करेंगे. दिस इज़ ऑल फॉर दिस लेक्चर. थैंक यू.